This is an exponential function. Exponential function where the exponent's actually x. You have 2 to the x, or y equals 3 to the x, or y equals e to the x. Hopefully remember what e is, 2.71828. So these are exponential functions. If you remember from other classes, hopefully, when you graph exponential function, you can, if I wanted to graph y equals 3 to the x, quickly, I'll make a table, x versus y. When x is 0, what is 3 to the 0?
0.
How about a 1? When x is 1, what's 3 to the 1? When x is 2, what's 3 squared? 9. When x is minus 1, 3 to the minus 1? 1/3. Very good. When x is negative 2, 1/9. So when you graph these exponential functions, they all look the same thing. They all look like this. And this is 0, comma 1. When x is 0, y is 1. This is what 3 to the x looks like. If you decide to graph 2 to the x, we'll have the same shape, except a little bit slower. Not as sharp as the other one. Will look like this. And if you graphed 5 to the x, guess what? The same shape, steeper. If you make the exponent negative, what will happen? Negative exponent, like 3 to the minus x, will be the reverse. Will look like that. Still going to go through the 0, 1. And if you did 4 to the minus x, it will be steeper. 2 to the minus x will be less. So the shape is very similar, either increasing or growth like this one, or decay like this one. What do you notice about this? Let's look at a few things. What's your domain for them? The domain is what? X is what? All real numbers. X belong to R. All real numbers. What do you notice about the range? Is the 0 included? No. Good. Y is greater than 0. It never hits 0. Well, anytime you see an exponential function in the same section or different, the following section is going to be the logarithmic function, the log. The log is really the inverse of the exponential function. That's what the log is. It's the inverse. Since the log is the inverse, I left a big space there, I don't know why. The inverse of the exponential function, that means what? For the log function, for this, what is the domain? Let me push it up there. The domain becomes what? X such that the domain will be the range of that. And the range will be what? Yep. And by the way, this exponential function, every time x was 0, what was the y value? 1. Guess what actually for that log function, every time x is 1, guess what the answer is going to be? 0. When x is 1, it's always going to be 0. So if you look at the graph for the log function, it is the inverse of this. Well, what's the inverse of that? Let's look at the function again. This is f of x, exponential function. To find the inverse, we draw a line parallel to that. And if you do the inverse of that, it's going to look like this. So this is the log function, and that's the exponential function. It's the inverse of each other. And I'm going over this because there's a lot of stuff I'm giving you right there, actually. You don't see it yet. But the first thing, before you even discuss what log is, it says, wait a minute, the log of 1 is always a 0. It's always going to pass through that point. It also tells you you can't take the log of a negative number or 0 because the domain for the log function is always what? Greater than 0. So you can't take the log of a 0 or negative number.